So this is an example of the time of flight questions, which invariably have been answered fairly poorly in the mocks. This is slightly more a simplified version because they've already kind of rearranged and amalgamated the equations you need to use for those questions. But what I'd like to do is just focus on this equation first, because I just want to show you where that equation's come from, because that's important for other questions they might ask you that are worth more marks for this. So this comes from the kinetic energy equation, which is energy equals half mv squared, and it comes from the fact that v, which is velocity, can also be written as distance divided by time. So essentially what they've done here is substituted this distance divided by time equation in for velocity and then rearranged. Now in terms of rearranging this equals half mv squared, the first thing you do is take the half onto the other side, so you have to multiply both sides by 2, so 2e equals mv squared. Then you need to divide by m, so 2e divided by m equals v, and then v squared, sorry, and then to get v by itself you'd have to square root both sides. So that would be how you'd have just v by itself, and then you can substitute in d over t for v. So instead of v, you can write d over t, and then to get d by itself, you'd then multiply both sides by t, and that'll get d by itself like that. So that's one way you can rearrange. Now clearly up here they've done it so that you've got t by itself. You'll notice that the expression inside the square root is the other way round for t, and that's because of the rearranging. Now actually what you want to do first is rearrange this equation so that you've got d as its subject, because what you want to be able to do is make the titanium 49 ion, the titanium 47 ion's equation equal to each other. And the fact that they both travel the same distance means that if you rearrange this to get d by itself, which we did at the bottom there, so d equals t square root 2e over m, d is going to be the same for both the 49 ion and the 47 ion. So you can say that t times 2e over m will equal t times 2e over m for both those ions, and we can substitute in the numbers now. So the time of flight for the T49 ion is 9.816 times 10 to the minus 7, and multiplying that by the square root of 2e over m. And the m, we've also got, haven't we, because we've got the masses of the two ions, so that's going to be the 49 ion, and that's equal to the time of flight which we're trying to work out times by 2e over 47. Now actually the whole way this works is that all of the ions are accelerated to the same kinetic energy, so these two e's are going to be equal to each other, so we could just write in there any number actually would work as long as they're equal to each other, because we know they're equal, so we can just write 1 in there. So 1 over 49 and 1 over 47. And then we can rearrange to get t. So actually t will equal 9.816 times 10 to the minus 7 times by the square root of 1 over 49 divided by the square root of 1 over 47. Now I'd recommend that you do lots of that individually and then put it onto your calculator. But if you did put all that into your calculator, then you'd get a time of flight of 9.614 times 10 to the minus 7.